In these notes, we're going to learn about exponents. So exponents are when we have repeated multiplication. So when we're multiplying the same number by itself, we get to use exponents. So for our first example here, we have 4 times 4 times 4. So that means we have 4 to the third power. You're multiplying 4 by itself 3 times. So 4 to the third power. The 4, the big number, is called the base. And then the little number that we write up top is called the exponent. Or sometimes people call it the power. And the reason is because when we read this out loud, when we read this part, again, here we say 4 to the third power. When we have it in general with letters, we would say x to the nth power. Now, third obviously doesn't have a th with it, but it's just whatever number, how you would say that number. We also can say 4 cubed, so we have kind of a shortcut. When we have an exponent of 2, we say squared. When we have an exponent of 3, we can say cubed. But that's really it. But you don't have to. You can always use the actual number. So we are going to take what's called expanded notation. So that means you have everything listed out. We're going to write it in exponential form, and then we are also going to get the value in our calculator. So we have 11 times 11. So 11 to the second power, 11 squared. Most of your calculators will have an actual squared button. So if you have one of these calculators, it's right here. So all the calculators will have an X with a 2, so that's your squared button. So what you do is you type in 11, and then you hit that squared button, and we write it as 11 squared, and then hit your enter or equals, and your final answer is 121. Now you also could obviously just do 11 times 11, but when you have lots of numbers like we have down here, this takes a lot less time. If you have anything other than squared, or you can even use this if it's squared, you'll use what it looks like this arrow button. So that would look like this, 11, and then this arrow says exponent, and then 2. So 11 to the second power is 121. If you have a little bit different calculator, yours will still look like this, an X, and then there's usually a box right here to show you that when you push that button, then you enter the exponent. So our next one, we have 1, 2, 3, 4, 5, 6, 7 2's. So 2 to the 7th power. So again, in our calculator, we are going to do 2, and then this exponent key right here, 2 to the 7th power, hit enter, and we get 128. These next two are very, very important. When you have a negative number as your base, you have to keep it in parentheses. If you don't, your calculator is going to give you the incorrect answer. So basically, if it already has parentheses in the start of the problem, you need to keep them there. So when you write this, you need to write it as -5, and then the 4th power goes on the outside of the parentheses. So when you type this in, you need to do the parentheses. So you're going to have parenthesis, -5, parenthesis, and then your exponent key, and then 4. And we have positive 625. So the reason it comes out to positive and why you have to have the parentheses, negative times negative, these two make a positive, and then another negative makes a positive. If we would have put another -5 onto here, then we would have had a negative left over. So something that to keep in mind, if you have a negative number to an even exponent, then your final answer should be positive as long as you do it correctly. What I want you to see is your calculator, if you don't put the parentheses in there, it gives you -625. Your calculator's not dumb. Your calculator is doing 5 to the 4th power and then making it negative. That's why it's so important that you have to put those in parentheses. Okay? If you have a negative number to an odd exponent, that will end up being negative, okay? And the reason is the evens, the negatives cancel each other out when you're multiplying. The odd, there will always be a negative left over for your answer. Same with fractions. You absolutely have to keep them in parentheses. If you just write 1/4 to the third power like this, that looks like only the 1 is to the third power. So you have to put 1/4 in parentheses and then to the third power. If you don't put it in parentheses in your calculator, it will not do it correctly. Now, if you use division, then you're going to get a decimal, so you'll have to change the decimal back to a fraction. If you use your fraction button, so if your calculator has a fraction button, or on these calculators you do parenthesis 1 ABC4 parenthesis. Okay, so 1/4, 1 ABC4, and then your exponent and 3 gives us 1/64. And again, don't just rely on your calculator. Make sure that makes sense. You can always go back and check. 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. So you know that your calculator did that correctly. Now we have two different numbers. So we have two 7s. So we're going to write 7 squared times 4 to the third power, or 4 cubed. 2 7s and 4 4s. Now, this next part is up to you. If you feel comfortable typing it all in, you can do that, or you can do each one separately. 7 squared is 49 times 4 to the third power is 64. So if you want to do them separately and then multiply, you can do that. 3,136 should be your answer. If you feel pretty confident with your calculator, you could do this. 7 squared times 4 to the third power. That's what it would look like. Or you can even use your exponent key twice. 7 to the second power times 4 to the third power. So any of those options are fine. You do not have to split it apart if you don't want to. I'm going to start with the negative first since it needs to be in parentheses. So -2 in parentheses to the third power. There are 3 of them. And then 8 to the fourth power. You can put a multiplication sign, but you don't have to. That's up to you. -2 to the third power is -8. Again, you don't have to write this out if you don't want to. And it's negative because there's 3 negatives. Okay, an odd number. And then 8 to the fourth is 4,096. You're going to get some pretty big numbers when you're doing exponents. So our final answer is -32,768. It's 768. Number 7, we have the parentheses again. So parentheses 2/3 squared, there's 2 of them, and then 9 squared. So again, you can use your fraction key. So you'll do parentheses 2 ABC3 parentheses squared. And you would get 4/9. And again, the reason is you would think 2 times 2 is 4 on the top, 3 times 3 is 9 on the bottom. 9 squared is 81. So 4/9 times 81 gives us 36. Again, if you feel confident and comfortable doing it all at once, it could look like this. Parentheses 2 ABC3 parentheses squared times 8 squared. Or you can use your other exponent key if you want. Oops, sorry, 9 squared, not 8 squared. There we go, and we get 36. All right, so those all have numbers, and we end up with numbers as our answers, even if it's a fraction. Now we have all variables. So this one we're just going to count. There are 9 A's, so A to the 9th power. You can't get a value from that, so that just doesn't get filled in. Number 9, this is the one that people make the biggest mistakes on. There are 2 ways you can do this. You can see these as 1, 2, 3, 4, 5 separate things. So then you need to put XY in parentheses to the 5th power. That is actually what's preferred since they are together. with multiplication signs, because you also could have it like that. All right. The other option is you could say there are 5 x's and 5 y's. So either of those are technically correct. This is the one that is preferred. So there's no value. This is absolutely incorrect. If you don't have parentheses or you don't have a 5 with both the x and the y, it will be wrong. When we have more than one letter, we like to put them in alphabetical order. So r would go first, and there are 2 of them. So r squared, or r to the 2nd power. There are 5 s's, so s to the 5th power. And there are 3 t's, so t cubed. That's it. Okay, so when there's just variables, just letters, you won't have anything in the values. Now we have both numbers and variables. We always put the numbers first when we have both. So there are 3 9's, 9 to the 3rd, and there are 6 k's, so k to the 6th. Again, if you want to put a multiplication sign, you can, but you don't need it. We do need to do a value, so you need to put in 9 to the 3rd to get 729 k to the 6th. You can't do anything with k to the 6th except for bring it along. So 12 will look just like this. -7 to the 2nd power. Now we have 3 m's and we have 2 n's. So -7 in parentheses squared, m to the 3rd, n to the 2nd. -7 squared is positive 49. M cubed n squared for our final answer. These last two are very different, where they have things with addition and subtraction. We cannot try to simplify any of the addition or subtraction. So this one simply stays as p minus 2. There are 1, 2, 3 of the same thing. So p minus 2 to the 3rd power, and we can't do anything with that value. Okay. So if there's addition or subtraction, it all just has to stay together. This one we have numbers and the addition subtraction. So first we would do 6 to the 3rd power, and then a plus b squared. There are 2 of them. So our final answer over here needs to be 216, and then a plus b squared. So anytime you have a number to an exponent, you need to change that to an actual number. And then the variables have to stay. Addition or subtraction has to stay inside the parentheses.